Hello and welcome, and what we're going to do in this video is we're going to look through assessment 5. So we're going to get straight into it and start with question 1 here. So this was a trig question, although I didn't tell you to use it. You've got to kind of use your knowledge to identify that you need to use trig here. So what we need to do is find out this length DC, because we need to calculate the perimeter. So we've got three sides. There's no rule that if we've got three sides of quadrilateral how to find the fourth one. We need to find some way of doing this. So to do this, what we're going to need to do is to draw a line here between AC. So, and then that way we split it up into two triangles. Now what I have seen some people do is I have seen them split up from D to B and then say both those angles have been halved. There's no rule saying that is the case. Okay, you can split up one angle, but that's no guarantee that the other angle is going to be half as well. So we want to do it this way because, and you might be thinking, well, we're trying to find DC. Well, if we can find AC, then what we've got is a right angle triangle where we know two sides. We can just use Pythagoras. So how do we find AC? Well, we've got two sides and the angle in between. So if that's the case, we can go ahead and use cosine rule. So we know that a squared is going to equal the 7 squared plus the 9 squared. Take away 2 times the 7 times the 9 times cos 75. Okay, and you could just put that all in your calculator and then square root, and we'll get 9.87. Okay, so now we know that this side here is 9.87. By the way, I know we've actually got A, B and C here. Technically this would be B squared, that I've just found. But as I say, these letters can be interchangeable. Just need to make sure you're consistent with them. So 9.87, make sure you're rounding to at least 3 significant figures. I see a lot of people only go to 2, and the problem, or even 1 in some cases, the problem with that is you could do more calculations with this 9.87. The more calculations you do, the bigger and bigger your rounding error will get. And at the end, your answer needs to be at least round to what I've got on the mark scheme here. So we found AC, so now we can use Pythagoras to find DC. Now remember, we've got the hypotenuse here, so we just need to do the square root of 9.87 squared, take away the 6 squared, which gives us 7.84. Remember, to answer the full question, we're asked to find the perimeter, so we won't just ask to find DC. So just make sure that you add up all these values at the end, and you should get an answer that rounds to 29.8 centimetres. I've said if you've been too liberal with your rounding, remember units by the way, if you've been too liberal with your rounding, then you won't get the answer that rounds 29.8 and you'll lose a mark there, or maybe even more. So going on to question 2 now, and we've got to do some sketches. So we've got 2 graphs to sketch here, and then part B is using what we've done to answer another question. So the first thing I'm going to do is I'm going to sketch the graph y equals x plus 2, 3 minus x. So when I want to sketch a graph, I need to find out where it crosses the coordinate axis. So I'll start by working out where it crosses the x-axis. And one of the most important facts in maths coming up, crosses the x-axis when y equals 0. Okay, because that x-axis, the equation of that line is just y equals 0. So if we set y to 0, then all we're doing is finding the solutions to this quadratic. It's already nicely factorised for us, so don't go expanding that out because you're going to make life more difficult for yourself. Just be careful, this last bracket here, 3 minus 3 gives you 0. Okay, so it's 3, not minus 3. So we've got where it crosses the x-axis. Now we need to decide what type of graph it is. Now if we times the x, the other x, and the minus x together, we get a minus x cubed as our highest power. So it's a negative cubic, so we need to draw the shape of a negative cubic, which will look something like this. Okay, it will look a little bit when we do our sketch. So let's go ahead and do that. Just get a line here. So it's going to cross the x-axis at -2, 0 and 3. It's going to come down like this, come up through the origin, and go down again. Hopefully yours is actually a little bit better than mine. And we need to make sure we put on the where it crosses the x-axis. Now in this particular question, we don't need to find where it's actually going to cross the y-axis because we've already done that. Because it crosses through the origin, so we already know where it's crossing the y-axis. But just be aware, if you were asked, if it wasn't the case, you would need to sub in x equals 0 to find out where it crosses the y-axis. So now what we're going to do is go on to part 2. We're going to draw the graph of y equals -2 over x. And this is just the shape that we need to learn. Okay? So you just need to make sure that you have learned what this shape is going to be. So if we were drawing 2 over x, you'd be drawing the graph in this quadrant here and this quadrant here. Because it's -2x, it's just going to look something like this. And something like this. Okay? All this 2 does is just it sort of stretches it further and further away from the origin. Okay, so if you did like a -4 over x, it would just be here instead. The asymptotes are still x equals 0 and y equals 0. So some confusion with some of you. Some of you thought that meant that the asymptotes were 2 and -2 now. No, the asymptotes are still x equals 0 and y equals 0 because you can't sub in x equals 0 because then you'll get an undefined solution because you can't divide by 0. And you'll never be able to make y equals 0 despite how big you make x. You can see here, you can make x be really large values and it will get really, really close to the x-axis, but it will never quite get there. So y equals 0 is still your other asymptote. So then we're going to do part B. And we're going to use our sketch. Okay, I think the comma's perhaps in the wrong place there. We're going to use our sketch to find the number of real solutions to this equation. Now, what we should notice is, and you know, it's a big hint when it says use your sketch. Okay, the fact that we've done that and it's telling us to use it should mean that these questions are linked to one another. Now, if we take the 2 over x from both sides, what we should notice is that on the left hand side we've got our first graph that we sketched, and on the right hand side we've got the reciprocal graph that we sketched. So what we'd do then, if we want to see where they intersect, we would just plot these on the same axes. Okay, and if we did that, we'd find that there were 2 solutions as there would be two points of intersection. Okay, so 1 mark for saying that there's 2 solutions, and then second mark for giving some explanation that you just be looking at where you cross. And say if you drew them on top of another, you just look at my pen here. I'd go down here, go up here, and then go down here. There'd be a solution in this quadrant, and there'd be a solution in the other quadrant. Moving on to question 3 then. So it's another sketch one, but now it's linked with the trig now. A little bit trickier this one. But still we can manage. So the first thing is we're just going to consider what is happening with this graph. Now what we can do is we can relate it to a graph we might be more familiar with. Just rub that out. So we should all be familiar with what the graph of sine x looks like. Okay, we're just doing this between 0 and 360. and it just looks something like this, where it's crossing at 0, 180, 360, and it ranges between 1 and -1. So now we'll consider what happens as we apply the transformation. Okay, so you can see there we've added 30 to the x. So going from sine x to sine x plus 30, this is a translation, because we're adding. When we add or take away, it's a translation. It's a translation of, and it's affecting the x's, okay, because you're adding 30 to all your x's. So remember, when it's changing the x direction, it does the opposite of what we'd expect it to do. So we actually have to take away 30 from all our x values. So what is x normally, we'll have to take away. So before, this crossed at 180, 360, and 0 as well. Now what we'll have to do is we'll have to take 30 off all those values. And what happens is it's going to shift to 30 to the left. Okay, and you can also check this, because before, sine of 180 would make 0. Okay, as you can see on our graph there. But now we have to sub in, we only have to sub in 150, because when we add 30 to it, we get 180, and sine 180 is 0. So remember, in the brackets, it does the opposite of what you'd expect. Then what we do is we then times it by 5. So we find sine of x equals 30, and then, let's try again. And then we times it by 5. So this is a stretch, because we're timesing, of scale factor 5 parallel to the y-axis. Okay, because you work out your sine values, now your sine, even with x plus 30, that still ranges between 1 and -1. But then you're multiplying by 5. Okay, it's affecting your y values, so it's change that's happening in the y direction. It does what you'd expect. It does actually times all your y values by 5. So let's now go ahead and sketch this. Okay, so before we would start at 0, but now this is shifted 30 to the left, so now we'd start here. So we're going to start somewhere up here, go up, come down. Yeah, again, hopefully your curve is a little bit, your sine wave's a little bit better than mine, and then we'll stop here. So remember, this point here that's 180, that's now 150 degrees. The point that was 360 is now 330 degrees. This now goes up to 5 and down to -5. A few of you said that it can't be correct because sine only goes between 1 and -1, but that's true. Sine x still does go between 1 and -1, but now you're multiplying by 5, so now it goes between 5 and -5. The only other thing that's missing here is we were asked where it crosses the coordinate axes, so that also includes where it crosses on the y-axis. And just like any other graph, and I'll keep going over it over and over again, if you want to find out where it crosses the y-axis, even though it's trig, it's still the same rule. We still sub in x equals 0. So if you want to find out the value here, we just sub in x equals 0. So we're finding 5 sine 30, and that's just going to be 5 over 2. Okay, sine 30, of course, being a half, so it's just going to be 5 over 2. So just make sure we make that clear on there. You can do its coordinates as well if you like. So we can move on to 4 now. So I'm going to do this in 2 parts. I'm going to do part A first on this slide, and we'll do part B on the other. So starting with A, now this is just 1 mark, so we're either going to get this correct or incorrect. So we start with 5 sine theta equals 2 cos theta. Now, you're even given the hint that you find an expression for tan. So, in order to make tan, we need to do sine divided by cos. So what I'm going to do is I'm going to divide both sides by cos. Now, when I divide the right-hand side by cos theta divided by cos theta, well, the cos thetas will cancel out. And you divide anything by itself, it'll always be 1. So we just get 2. So we know that sine theta divided by cos theta will just be tan theta. So whenever you do sine over cos, it will become tan. Okay, it's a really important identity to learn and use a lot. And some people would just leave it like this, 5 tan theta equals 2. That's not correct because you're asked to find an expression for tan theta. It's like we have to make tan the subject. Okay, so we then just divide both sides by 5. Few people getting the dividing mixed up. Some of you had 5 over 2 tan theta equals 1, but then you didn't divide by 5 over 2, you multiplied by 5 over 2. You've always got to do the opposite, remember. So then we just get tan theta equals 2 over 5. If you had the time in the exam, you could, sort of when you get back to when you've solved your equation at the end, you come back to this and sub some values in, check you've got it right. But obviously you need to find some values of theta first, which is what we're going to do now in part B. So whenever you see this word hence, okay, it should be a massive clue that what you did in part A is going to help you in part B. A lot of people went and tried to solve this again. I mean, and you can, and you probably would have some success with that. But just look, the only difference here is theta has been replaced with 2x. So instead of solving this for, so you just seen the first part that tan theta equals 2 over 5. All we're doing now is, this is going to be tan 2x equals 2 over 5. That's all we've done. All we've done is just replace theta with 2x. So we're asked to solve this in the range of 0 to 360. But we've got a 2x here, so we're actually solving it for all the 2x values we find. We solve between 0 and 270. Okay. So what we'll do is we'll go back and call, we'll let 2x equal theta. Okay, so what we're going to do is we're going to find all the solutions to theta in this range between 0 and 720. Another thing that you can look at in terms of finding how many solutions is if tan x between 0 and 360 for the majority of values would have 2 solutions, then tan 2x will have double the amount of solutions. Okay, if you make it tan 2x, you are compressing the graph and the frequency is going to be double, so you get double the amount of solutions. Okay, so we're going to solve tan theta equals 2 over 5. So we find inverse tan of 2 over 5. When we do that, we just get 21.8 degrees. But we need to find the other solutions. Now tan should be your favourite identity, because all you need to do is just simply plus and minus 180 from it. Okay, we don't do 180 minus like we've been sine, we just have to add 180s to it or take 180 from it. But obviously I'm going to take away 180 here because that will take us out of range. So all your solutions are theta. Just bear with me a second, just it's locking up a bit. So for all your solutions are theta, There we go. We get 21.8, and then just keep on adding 180s to this. We get 201.8, 381.8, 561.8. If you add any 180 any more times, you can just ignore those values because they will take you out of range. Okay. So there are your values for theta, or there are your values for 2x. So if you found inverse tan of 2 over 5, you could find all these solutions. But they're the solutions to tan 2x. We just want to find it for x. So we just need to half all of these values. Okay, if 2x equals theta, then x is just simply theta over 2. So we get 10.9 degrees, 100.9 degrees, 190.9 degrees, and 280.9 degrees. There might be some of you that can recognise that if you did inverse tan of 2 over 5, and then you could divide that by 2, it would be 10.9. But you've got to be careful, you can't then add 180 to that, because you need to consider what the new graph would look like, and that instead of having a period of 180, you'd have a period of 90 degrees. So that's why I always recommend doing a substitution like this, because then you could just use that same identity again and again and again, find your values with whatever you've substituted, and then half. Okay, it takes a lot of practice, trig, but with time you will get there. Okay, number 5 then. So this is another transformations question. So what we've got to do is consider the different types of transformations that happened here, and then plot the sketch. So we don't know what this equation of this curve is. Okay, we have no idea. We're just given certain key features. We're given the roots here, and we're also given the maximum point. And we need to show what happens with those x-coordinates and the maximum point when we apply different transformations. So the first transformation we need to do is a stretch of scale factor 2 parallel to the y-axis. Okay, so what that does is that means you multiply all your y's by 2, because what happened is you put x into your function, you get a value, and then at the end you times that by 2. So that would just mean your values have doubled. The second one is a reflection. Okay, the second one is reflection here. And the other thing you need to notice is what axes are you reflecting in. So this is a reflection, and it's not the x-axis, it's the y-axis. Basically what this does is it takes all your x's and then it makes them negative, and takes your, well, all your positive x's become negative x's, all your negative x's become positive x's. So it's just reflecting here in the y-axis. Okay, so it's really important that you know when the minus is inside the bracket, it turns your positive x's to negative x's to positive x's. And when the negative is outside the f of x, well, that means you work out your value, and then your what was positive y now becomes negative y. Okay, so if it's inside the bracket, it affects the x's, and if it's outside the bracket, it affects your y's. So make sure you get that right, because I saw a lot of people reflecting in the x-axis instead, which is incorrect. So let's get ourselves some axes and draw these. So I'll draw a first. If it's going to let me draw. And then we'll do one for B as well. So our first one, say it's stretch of scale factor 2 parallel to the y-axis. So what happens there is, and so I need to work on sketching on here, is because it's stretch of scale factor 2 parallel to the y-axis, all your y values will stay the same. Sorry, all your x values will stay the same. It's only your y values that are affected. Okay, there's no change happening to the x, So all the x's will stay the same. It's your y's that get multiplied by 2. So your roots are still going to be 1 and 4, but now your y coordinate of the maximum point is now going to be 10 rather than 5. The x coordinate is still 2 because x is not being affected. In the second transformation, it's a reflection in the y-axis. Okay, it's change happening inside the bracket, so it's only the x's that are affected. So instead of now being 1 and 4, -1 and -4 are now your two roots. Okay, instead of the maximum point being at 2, 5, it's now going to be at -2, 5. So all your positive x's, your 1, your 2 and your 4 have now become a -1, a -2 and a -4 respectively. The 5, the y equals 5, is still y equals 5 because it's a reflection in the y-axis. Your x's will change, your y's will stay the same. Then finally part C, write down the value of the constant a. So the maximum point on the curve with the equation y equals f of x plus a is on the y-axis. So if you look at this graph here, well, what would have happened to it if it's now going to be on the y-axis? Well, it's shifted 2 to the left. Okay, so if x was 2 before, if it's going to be on the y-axis, then x is 0 because of course it crosses the y-axis when x equals 0. So if it shifted 2 to the left, this would be a transformation. Now remember, changing the x direction does the opposite of what you'd expect. So it wouldn't be that because you take 2 off the x values, the transformation is actually going to be f of x plus 2. So a would simply just be 2. Okay? Because now, to get 5 now, you'd have to put, when you put an x equals 0, where it crosses on the y-axis, f of 2, we know, gives you 5. And the last question then, another trig equation, another identity that we're going to need to use here, which is why it's so important to remember identities. Now, here we've got a sine squared x and we've got cos squared x. Now, why we can't solve that straight away is because we've got 2 different trig functions. We just want one trig function. The fact that both of these are squared, it really does make it almost certain that we're going to be using our second identity that we learn, which is sine squared x plus cos squared x is equivalent to 1. So then we've got the choice whether we want to rearrange this for sine squared x or we want to rearrange this for cos squared x. There's no other sine x's or cos x's there, so it is our choice of what we want to do. It's probably slightly easier to get rid of cos squared x, just leave it all in sine. You might see why that is in a second, but really it's just as fine if you want to change the sine squared x here. There's 2 different ways you can do this. So I'm going to take away sine squared from both sides. And then we just leave us with this, okay? I'd also recommend making sure you learn these identities rearranged like this, because very rarely will we actually use it in this form of sine squared x plus cos squared x equals 1. Often it's just going to be the fact that you want to replace the cos squared x or you want to replace the sine squared x. So make sure you're aware of those identities and just make sure you're careful with your rearrangement. So now wherever I see cos squared x, I can replace that with 1 minus sine squared x. If you did rearrange this for sine squared x, just be careful that when you put in 1 minus cos squared x, you times each of those terms by the 2. Okay, it's not a problem for us here because we're just adding it, but just also be aware if that were a negative, you need to be careful with your signs. So when we get to here, we just need to collect together the sine squared x's. A lot of people thought this was it, this was the quadratic equation, but we've got 2 things that are squared. So we need to make sure we collect together like terms. So 2 sine squared x, take away sine squared x, it's just going to leave you with a sine squared x. We've got the plus 1 there. So we're just going to rearrange it so that we get sine squared x equals 1 over 9. If you got to this point, you've got 2 marks. Okay, 1 mark for putting your substitution in, and then your second mark for getting down to this point. And remember, the goal is we want to find what x is. So we've got this sine squared x equals 1 over 9, but we can't solve for sine squared because we don't have an inverse of sine squared x. We only have inverse sine x on our calculator. So we need to square root both sides. And please remember, when you square root 1 over 9, you will get a positive and a negative solution, because minus 1 over 3 times minus 1 over 3, it does equal 1 over 9. I've seen people lose loads of marks over this over the course of this year. It's a really silly mistake. We need to stop doing this. Okay, you're losing marks that I know you can get. So we've got 2 equations to solve now. So one of those is sine x equals 1 over 3, and the other is sine x equals minus 1 over 3. So we find inverse sine of 1 over 3, which gives us a principal solution of 19.5. Try again. Okay, now normally what we do is we consider all the solutions. Let's just look at our sine graph. Just from 0 to 90, there is just going to be the one solution for a third. And then we want to do inverse sine of minus 1 over 3. Again, let's look at the graph. Just between 0 and 90, so that's 0, this would be 90 here. We just get there's just one solution to find, which is minus 19.5. We're only asked to find in this quite small range of minus 90 to positive 90. Just put that there. So there's only 2 solutions, because normally we might do 180 minus 19.5. We might even sometimes add 360 to it, but they are well out of range. Same thing with the other one. We could do 180 minus 19.5, but yet again that would be well out of range. So our only solutions here are x equals 19.5 degrees and x equals, what's going wrong there? X equals minus 19.5 degrees. If you've got any more questions, please leave some comments in the comment section below. Alternatively, just ask questions in class. Hopefully this has cleared everything up for this assessment, and hopefully for the next one and for your mocks, which are on the 18th of December, should be all clear.